Hey, what's going on, everyone? Welcome to my first tutorial in over 3 years. If you look at my account, you see that a couple years ago I did a tutorial showing off a web service tutorial, parsing some JSON, and another tutorial trying to replicate the iOS 5 hamburger layout, which has become so popular. And learned quite a bit since then. I don't know why I actually stopped doing the tutorials, but after I logged into my YouTube account the other day, I was actually pretty shocked to see that those videos had gained so many views, and I feel like I have a bunch to say about Swift and kind of what I've learned and all the different ways that I've failed at Swift, and just might as well share them with you guys. So hopefully this helps. First one back, this tutorial is kind of pretty fitting. We're doing it on Grand Central Dispatch, and we're going to do a bit of a wrapper around GCD, a kind of Swift-like wrapper. And the reason this is fitting is because today is the day that Apple announced that Swift is officially open source. You can check it out at swift.org. And if you do a little bit of reading, you're going to find that they specifically state that concurrency in Swift is still up for debate, and it won't be coming anytime soon. And they're essentially just telling you, hey, just use Grand Central Dispatch. So hopefully this tutorial will still be valid in a couple of years. But yeah, let's get right into it. So what is Grand Central Dispatch? If you've never heard of it, well, it's a super important concept in iOS and OS 10. Oh man, I might get this wrong, but I want to say that Apple open source Grand Central Dispatch in 2009 after Snow Leopard came out. Oh man, that could totally be wrong, but I know it was around 2009 that they open sourced it. And essentially, what it is, it's a way of dealing with concurrency and processors with multiple cores. So they're essentially providing this abstraction layer over threads, and they introduce this queue-like system where you create a queue and you say, hey, I would like to run this block of code on this queue, and it's going to go ahead and behind the scenes create and destroy threads to run that block. And there's two types of queues by default. You get a serial queue, and you also have concurrent queues. Serial queues, it's first in, first out. So if you put 10 blocks on the queue, each of those blocks is going to run in order, regardless of what threads they actually run on, but the queue is guaranteeing that they run in order. If you have a concurrent queue, there's no guarantee as to what order they run in. The CPU is just going to try and run them all as quickly as possible. So what do we actually want to do here? Well, we'd like to come up with some syntax like you can see here where we want a structure called dispatch, and we would like to call a method called main, pass in a block of code that we'd like to run, and we would like this code to execute on the main thread where we can do any UI related tasks. And then similarly, we'd like another function called async where we would like that block of code to be run in the background. So really concise, really simple syntax, but it gets more interesting than that. So we can do some cool things here as well, where let's actually extend that main function before, and we want this block of code to run on the main thread, but let's actually delay it by 2 seconds. So this is a nicer way than dealing with something like NSTimer to try and do this, or even better, in the next example, literally getting rid of NSTimer, where let's say we want a block of code to run on a background thread every 2 seconds and keep repeating. So let's try and come up with some function here. We're going to call it async timer, a delay of 2 seconds, and you see you actually get a handle to that timer as t, but that block hello background is going to keep on running approximately every 2 seconds, or as best as the CPU can do. So that's pretty much it. Let's actually jump straight into code. Yeah, let's pop into Xcode here. So I have a blank project that I set up, literally did nothing to it. You can see it's just the default single page app. So let's go ahead and add a new file. Let's make a Swift file, and let's call it dispatch. Cool, so brand new file, and let's start out with a public struct that we're going to call dispatch. And in this struct, we're going to add our static method. So this is going to give us dispatch.main, dispatch.async. So let's actually knock out that first one right away. So public static func main. All right, so what is main going to do? Well, main needs to take in a block. We know we need to do that first type of syntax. And a block in Swift is the same thing as a reference to a function. It's just something that takes in arguments, runs a block of code, and it can return something or nothing. And we're actually going to be using that syntax quite a bit, so let's go ahead and just define a type alias here so we can reference it a little bit easier. So now we can say that this just takes in a block. All right, let's see, what is this complaining about? Oh, okay, so because it's a public struct and a public function, excuse me, this needs to be public as well, because if other sources are trying to use this code, they need to be able to get access to this type alias. All right, so let's get access to the main queue, and Grand Central Dispatch has a really easy way of doing this. Is a function called dispatch get main queue, and then they have another function for dispatching a block onto a queue. So it's passing our queue, and you'll notice that the type in the second argument, the block here, is called the dispatch block T. If you actually just go look at that dispatch block T, it is just an empty block, just like here. So Swift is smart enough to be able to convert our definition of a block over to the Objective-C or C version of the block, which Grand Central Dispatch is written in. So we actually don't have to do anything. We can just pass in block, and you'll notice if I build this, the build will succeed. Now we can actually go over here, and we get that dispatch.main, and we can pass in that trailing closure and say, hello main. So if I actually go ahead and run this, you'll see that hello main, hello main actually gets printed out to the console as expected. So let's go back and let's try and implement the async function. So same deal, we know this is going to have to take in a block, and it's not going to return anything. But now we don't want to dispatch to the main queue, we want to create our own. So Grand Central Dispatch is a way of doing this. It's a function called dispatch queue create, and takes in two parameters, a label and an attribute. So you could technically pass an empty string here for the label, but it's helpful to provide one, because when you're debugging, if you're using Fabric or Crashlytics or whatever, the thread names will actually show up in your stacks, which helps you out a lot. In general, for me, I tend to do reverse notation for these, so com.abarba.dispatch.async, and for the attribute, this is what specifies whether it's a concurrent queue or a serial queue. So let's make it serial. And now it's just like it is in main. So we have our queue. That's literally all there is to actually creating one. Let's call dispatch async, pass in our queue, pass in our block, and there we go. That's all there is to it. So this block of code is going to run on a background thread managed by Grand Central Dispatch. So if we go back to our view controller, what we can do is call dispatch.async. We'll say hello background, and actually spell hello right that time. So let's run this, and you might be surprised to see that the thread that ran in the background actually printed to the console before the thread that ran, or the block that ran on the main thread. So you can tell here that something is definitely going on, where this thread is for sure not happening on the same thread here, otherwise this condition wouldn't have happened. So cool, so we're on our way. And now let's get a little bit fancier. So we want to implement that syntax where we could actually delay the execution of the block. So let's copy main up here. Let's create the same function, but let's actually add a variable here. All right, so now we want to be able to pass in this first argument of it's some number of seconds that we actually want to delay this block. And GCD has a great way of doing this. There's another function called dispatch after, and it takes in this thing, a dispatch time t, which we're going to get to in a second. Let's just make it 0 for now. It also takes in our queue, just like before, and it takes in a block. So Now here's the tricky part, is this first parameter, this dispatch source t, so dispatch time t. So if you read the documentation for this function, what it says is it will dispatch this block the given number of nanoseconds from now. So we're passing this in as seconds, so we need to convert this over to nanoseconds. So let's create a variable, and we need to create this dispatch time. And you'll notice this takes in two parameters here, the when and the delta. So the when is now. We want this to happen, what's this, dispatch time now. So the start is right now, and then the delta is, this is going to be an int 64. And we actually just want to take our delay, and we want to multiply that times the number of nanoseconds there are in a second. So we can do that with a nice constant that is built in, and sec per sec. And there you go. So now we have our after, which can neatly fit in to here. And let's go ahead and copy this, because we also want to be able to do this for async. So let's change this to async. But we don't want to use the main queue. We would like to use the background queue. So just go ahead and copy that. So now we're creating another queue, giving it a different label. And let's go test these out. So now, if I actually run dispatch.main, you notice I can pass in something like 2.0 and print hello 2 seconds later. And let's copy this. Do the same thing for async. Let's do this 0.5 seconds later. And let's go ahead and run this. Cool. So hopefully you saw that in the bottom here. I'll run it one more time, but basically the hello background once again happened first, hello main. Then this hello 0.5 seconds later, that happened on a background thread about 0.5 seconds later, and then sure enough, the one dispatched 2 seconds later happened 2 seconds later. Sweet, so we're rolling right now. But let's actually simplify this. Let's do some nice Swift things here and kind of break this down. So a couple ways we can do this. Well, one, we want to be more flexible. If you're calling these functions, you don't always want this function to create a block for you. You might want to, or a queue for you. You may want to pass in your own queue. So let's make the first parameter for this function a queue, but let's take advantage of Swift's ability to have default parameters, and let's actually delete this. And now we need our comma. Cool. So now you'll notice if I try and build and run this, it still works. So why does that work? You would think that this would fail because we're passing in a block and not a queue. But again, Swift is smart enough to know that, hey, we passed in a type of block and we didn't pass in a type of queue, so we're going to go ahead and use the default here. And it knows that we're just going to use our trailing block syntax. So pretty cool of Swift to be able to figure that out. And now, hopefully you guys can see where I'm going with this. We can actually simplify this, and let's just call async. Let's give it the queue we want, which is dispatch get main queue, and let's give it our block. So now we're actually calling our async function down here, but we're passing in the right queue. So that all still looks good, but we can do better than this still. Let's actually add a delay here as well, with a default delay of 0.0 seconds. And now what this allows us to do is, let's actually copy this and paste this down here. And now when you call this function, you have the flexibility to pass in a delay and your own queue And this lets us simplify this function even further. We can actually get rid of this. Let's add a delay here with a default time of 0 seconds. And now let's pass in our delay. If we build this, okay, so you notice it failed, and you're going to see why. Alright, so the issue here is in async, because that first, so in Swift, the first parameter never requires a label. All your subsequent labels do, or arguments do. So in this case, we actually need to put the delay here, and this is a good thing. I think this is more clear. If you just call it dispatch.async 0.5, that's not really clear to me. I actually like having the label here, so now you'll notice this succeeds in building, and if we run this, we're going to get the exact same results as we did before. But I actually want to fix this. I don't like this 2.0 for the main. I also want to require the label. And to do that in Swift, you literally just repeat the label, and that's it. So now you see we have our error up here because we have to go back, and here we go. The compiler's even helping us out a little bit and add that label, and we can build and run. Cool, so we're doing pretty well so far. Let's keep on going and let's implement timers. And it's also a good time for me to talk about code organization. And what I generally do is I break up a lot of my code into extensions, and I actually try and keep the top level class or struct almost as bare bones as possible. So I have an extension here with those same functions. You notice it still builds fine, but now this lets me break up my functionality a little bit. And let's go ahead and extend dispatch, and this is where we're going to actually do our timers, is down here. And you'll notice up here we get this breakout for free in Xcode, which is really helpful. Alright, so let's make a new function. Let's call it timer. In this case, it is actually going to return something. We need a handle to this timer because we can't let this thing run forever. So we are going to return something. That thing is a dispatch source T, which is a reference to some block that's running repeatedly. And there's a really easy way to make one of these. And it is dispatch source create. This takes a type. And the type that we want is dispatch source type timer. And for some reason Xcode doesn't complete that, but trust me, it is a type. Okay, so these next two parameters, handle and mask, I'm going to be honest, I actually have no idea what they are. So if you guys do, please in the comments let me know. I haven't actually read the documentation for dispatch source create. I really should, but I didn't. And this last parameter is a queue. So let's kind of do the same thing that we did up here. Let's take advantage of this default block syntax, or default argument syntax, and let's pass in our queue. So we have a timer, we created it, we're going to return the timer. Obviously there's some big things missing here. We didn't specify how often the timer should run, and we didn't specify the block that we want. So let's go ahead and do both of those. So we're going to take in a block, and I think in the slides I called the delay, but let's actually call it interval. And for the interval, I'm actually not going to provide a default value. Doesn't really make sense. If it was 0.0, that definitely doesn't make sense. You don't want any timer trying to fire that quickly. So that's going to be a required parameter. All right. Now what we want to do is we want to actually set how frequently this timer is going to run. And the way we do that is a function called dispatch source set timer, pass in our source, which is the timer we created. Same thing, when do we want this thing to initially fire? So I want it to fire right now. Dispatch time now. What's the interval we want? Well, we have to do the same thing that we did before. We have to do this little bit of conversion. So let's copy this, because we have to convert this to nanoseconds, and this is interval. And then the leeway says, how much leeway should I give this timer if the CPU is under load? And this is in nanoseconds. So for example, if I make this 100, the timer might be off by about 100 nanoseconds. I don't really know what a good value for this is. So I think what we're going to do is actually Do I want to do that? No, I'll let you guys do that. I was thinking about doing another parameter so you can change this, but I'm not going to do it right now. So we're just going to leave it as 100 seconds. Let's see, what is this complaining about? uint64. Okay, there you go, Swift. So yeah, make that an unsigned integer. All right, so that basically tells the timer how frequently it needs to run. Now we actually have to set our block. And there is, of course, another function to do this, dispatch source set event handler, pass in our timer, pass in our block, and one last thing, we want this thing to start firing, and that is dispatch resume, and we pass in our timer again. So that is it. This will create a timer with the passed in queue, and you're going to see this will run continuously until we stop it. We'll talk about that in a second. So let's create two more functions. Let's call it timer main. It needs to return this, and we need these two parameters, and we're just going to call timer. We're going to return timer and pass in the main queue. So we want to run this on the main thread, and then we're going to pass in our block as well. Did I forget anything there? Oh, interval, obviously. Cool. So that works as expected, and you know what, to be consistent, let's actually call this async. And there we go. So now let's go back to view controller, and let's actually watch this run. Dispatch timer main. Let's run this every 0.5 seconds. I'm going to do the same thing. I'm going to require this interval argument, but let me just show you that this does work. Let's go ahead and run this. Oh, look at that. It doesn't work. Why doesn't it work? So this is interesting. So this has to do with automatic reference counting. This returned a handle to that timer, and I did not store it to anywhere. So we had a reference count of 1. As soon as we returned it, nothing held on to it. That reference went to 0, so this timer was deallocated immediately. So let's actually keep a reference to it. So now I'm going to set my reference, and this needs to be var because this is not an initializer. Now let's run this, and let's hope that this actually works. And as you can see, hello timer is going to keep printing out forever and ever. So now we need a way to invalidate this timer, and once again, there's a method in Grand Central Dispatch to do this, but let's get a little bit more creative. Let's actually make an extension on dispatch source t, and let's just create a function called invalidate. And I think it's kind of nice to return yourself here. So let's return ourself, but in this extension, let's actually invalidate ourselves. And what this lets us do, if we go back to the view controller, let's say dispatch.async, let's do a delay of 5 seconds, and now we can say self.timer.invalidate, so we get that function because it's an extension on dispatch source t. Now let's make this 4 seconds. Let's go ahead and run this, and you're going to see that timer run for about 4 seconds, and then it is just going to stop. And there you go, it stopped. So I think that is pretty much everything I wanted to cover. I guess the last thing is just making that interval argument required here. And again, the way you do that is you just double up that parameter. If I build this, it should fail. Let's go back here and actually specify that interval. And let me see if we change this to timer async. Is it also required? It should be. All right, what is the, yeah, cool. I don't think this should work. Let's find out. Nice. All right, cool. So that is what I wanted. All right, guys, so that's everything I wanted to cover about Grand Central Dispatch. I know it's not a lot, but hopefully this helps you guys write a little bit cleaner code and throughout your applications. Let me know if you have any questions, and I'll see you in the next one.